A classroom has a row of 35 coat hooks. Paulina likes coats to be equally spaced so that there's the same number of empty hooks before the first coat, after the last coat, and between every coat and the next one. Suppose there's at least one coat and at least one empty hook. How many different numbers of coats can satisfy Paulina's pattern? So for this problem, let's make a variable to represent the number of coats. I'll call it n. So n is the number of coats. Now we require that n is at least 1 because there's at least one coat. However, we also require that n is at most 34 because there has to be at least one empty hook. So n is between 1 and 34 inclusive. Now we know that because there are n coats, there are going to be n plus 1 gaps of empty hooks in between the n coats. So they're going to be n plus 1 gaps of empty hooks, and each gap is going to contain the same number of empty hooks. So because we have n coats, this means that we're going to have 35 minus n empty hooks. And moreover, 35 minus n has to be a multiple of n plus 1 because there are n plus 1 equally sized gaps in between the coats. So 35 minus n has to be divisible by n plus 1. So this is what n has to satisfy, along with this inequality. Now, instead of just manually testing every value of n, we can save a little bit of time by realizing that if 35 minus n is divisible by n plus 1, this is the same as saying that 36 has to be divisible by n plus 1. Right, because all I did was add n plus 1, so that's not going to change the fact that whether the first number is divisible by n plus 1. So this means that an equivalent condition to check is that 36 has to be evenly divisible by n plus 1. Moreover, n has to be between 1 and 34 inclusive. So using this, we can list out the factors of 36. Noting that n has to be at least 1, this means that n plus 1 has to be at least 2. So the factors of 36 will be 2, 3, 4, 6, 9, 12, and 18. Note that 36 does not count because that would imply that n equals 35, which is invalid. Alternatively, you can use the formula for the number of divisors of a positive integer, but because 36 is small enough, it's not too hard to just list them out manually. So this means that n plus 1 can be any of these 7 values, and therefore n can be any of the values obtained by subtracting 1. And therefore, we can conclude that there are going to be 7 values for the number of coats, which is choice D.